All right. So basically, first of all, you need to know about the source of the radiation, which is in this case hollow cathode lamp. Okay, so hollow cathode lamp, you need to know what is the why this hollow cathode lamp is so special. You need to know in terms of what elements are present at the cathode. Okay, so does the hollow cathode lamp allow simultaneous analysis as what as ICP allows? Okay, so you need to know about this. And I've also explained on the process that have been occurring inside the hollow cathode lamp. The hollow cathode lamp contains inert gases such as argon, so it bombard your cathode, which contains the element of interest, and then what happens, excitation and then emission. Okay, so you need to know about all of these processes. All right. Okay, so we're moving onto the next source, which is electrolysis discharge lamp. So this also you need to know about the functions of it. What are the advantages of EDL as compared to HCl? Okay, you need to know. All right, so second part is the sample introductions. So the sample needs to be in a liquid form as compared to graphite furnace. Graphite furnace you can have in liquid ke solid ke even slurry. Okay, so but for flame AAS it needs to be in liquid form. All right. So what does the sample introduction constitute? You need to have a flame which is created by using ethane and oxygen fuel. All right. In the flame, you will have the atomization process. Okay. So you need to know about the atomization process. Let me look. Okay. So atomization, you need to know the process from the aspiration, the first part. Okay. So after it's been aspirated into the atomizer into the atomizer, it needs to be converted into a solution first. Sorry, it need to the solution needs to be converted into aerosol, and then we remove the solvent, and then we vaporize the sample. So all of this at atomization process you need to know by heart lah. Okay. But remember, for flame AAS, ionization is not required, or bukanlah not required, is undesired. Okay, because for ionization it will have some interferences later on. Okay, I've explained this towards the end of the lecture lah. Okay, and then after that, for atomization you have looked into the flame, and then we are look into the graphite furnace atomizer. All right, so for this special atomizer, it is flameless, so it doesn't have a flame. It just have a graphite furnace. It's just like a tube where it's straight away heated electrically. All right, so for this graphite furnace atomizer, there is the sample preparation has been minimized, so you don't need to have it in liquid, but you can have it in solid, even in slurry form. All right. All right, so this is an example of graphite furnace AAS. All right, so basically this is how the graphite furnace looks like in terms of the illustration. So you just put your sample in, and this graphite tube will straight away being heated up, and then the atomization processes will occur in this graphite furnace tube lah. Right. So, okay, you also needs to know about the differences between flame and graphite furnace AAS. So, what are the differences? What are the advantages, and what are the disadvantages? All right. Okay, the application of AAS also we have looked into the mercury analysis, even the trace metal element determination. And also we have looked into the determination of arsenic in cockles. Okay, so we need to have some sample preparation for it, which I think that we'll be looking it into depth. I think about next week, if I'm not mistaken lah, for sample preparation for inorganic substances. Okay. All right. So Let me look what else. All right, so we have looked into flame AAS, we have looked into graphite furnace AAS. Now we are going into much more specific type of AAS. All right, so we have hydride generation AAS, and this some metalloids elements are able to form volatile covalent hydrides. Okay, so this what are the functions of hydride generation? What are the elements that can be analyzed by hydride generation AS? So all of this you need to know. All right. So the most specific one in this one, in this case, is the cold vapor AS, where it is only for the determination of mercury. All right. So basically, you need to know on what makes mercury special for only to be applied for only cold vapor. Okay, so you need to know about that. All right, so what are the advantages and the limitations of both hydride generation and cold vapor mercury? Okay, all right. So also we have looked into the spectral interferences, and then how are we going to correct it. Even we have looked into the matrix interferences and chemical interferences. And lastly, we have looked into the ionization interferences. This is what I've meant before, where in AAS, flame AAS, we don't desire the ionization of atoms. All right, so how are we going to eliminate these ionization interferences? Is by adding an easily ionizable element. In this case, maybe 0.2 to 0.5% of potassium. All right. So why does addition of potassium makes it much more better? Because the easily ionizable elements will be ionized first. Okay. So it will create a surplus of electrons, which the solution will shift towards, the equilibrium will shift towards the production of ground state rather than production of ions. All right. So, ada soalan? Any question up until this point for chapter 3? Any question? Nurul Danishah, do you have any question?
No question, Doctor.
No question. Everything is clear, yeah?
Yes, clear so far,
Sharvin,
Doctor.
Sharvin, ada soalan?
No questions, Doctor.
No questions. Okay, all right. All right, if there is no question, I will just continue on chapter 4, which is the ICP. Okay, so is this the emission spectroscopy? So basically, we have looked into before this atomic absorption, now atomic emission spectroscopy. Okay, and then we've also towards the end of the lecture, we also looked into the mass spectrometry. All right, so it's still the same in terms of what you need to know for emission spectroscopy. Of course, you need to know about the principle of it. What does emission means, and how does the emission being radiated onto your detector later on. So you need to know the differences of AES and AAS, as what have we been looking into this illustration in this figure. You have looked that in AES there is only flame, there is no source, but for AAS there is source and then there is flame. You need to know the differences and why does these differences happens. I've already elaborated this inside the lecture. All right. So for AES, you can have all of the atoms in the sample are excited and detected simultaneously. So that is one of the advantages of atomic emission spectroscopy as compared to atomic absorption spectroscopy. All right. So there are three types of atomic emission spectroscopy. So we have been looking into flame photometer, and the second one is the ICP OES, optical emission spectroscopy. And then we have also been looking into the plasma mass spectroscopy, spectrometry. Okay. So I've also explained on the flame photometer, apakah perbezaan flame photometer ini dengan ICP. Is just a simple emission spectroscopy, alright? So this is the illustration or the figure of the emission spectroscopy, the flame photometer lah. So it's just a simple one, alright? And then we have been looking into the plasma optical emission spectroscopy. So for this one, you need to know on what is plasma actually. So this is one of the questions that usually that is popular to ask lah. Okay, what is plasma actually? So you need to know plasma is not a flame. It is not being ignited by ethyne ke tadi tu kan yang kita tengok dekat dalam atomic absorption spectroscopy. So what is plasma actually? You need to know the definition of plasma. Alright, and what are the normal analytical zone dekat mana, and then what are the temperature usually being done into your analysis. Alright, so the theory of ICP, so you need to know about what does ICP has again, what are the advantages of ICP on top of your plasma atomizer, plasma apa tadi, flame photometer, and ada juga dekat you, what are the advantages or disadvantages for your ICP-MS. Okay, okay, so we also need to look, we also have looked into the processes in ICP-OES. These are the same as what we have looked into the apa tadi tu, yang atomization process inside AAS. So basically it corresponds to the same one. Okay, so for ICP OES, we have until ionization as well, but ionization is desirable in ICP-MS, okay, as compared to AAS lah. Alright, so the advantages, these are the one that I've mentioned before, the advantages over flame photometer, and then what are the disadvantages. Alright, so the instrumentation part also is a little bit complicated in terms of what are the the ICP and sample interaction system. You need to know the nebulizers, the spray chamber, and then we moving on to the radio frequency generator. So it provides power for the generation of plasma. Okay, so you need to know also the plasma torch, the what are the flows that correspond makes up your plasma torch lah. We have plasma flow here, auxiliary flow. We have your nebulizer flow from your sample, and then we have the injector tube here. All right. Okay, so how does the emission has been detected in ICP-OES? So it's been using CCD, charge coupled device. So you need to know on how does it being detected. All right. Okay, the application of ICP-OES, and then we have also looked into the last part, which is the plasma mass spectrometry. So basically, when we are talking about mass spectrometry, the separation is based, or the identification is going to be based on the mass of the ions. Okay, so basically this is a little bit much more complicated as compared to ICP-OES, because in this case, from the plasma here, the ions will have some will be moving onto interface, plasma spectrometer interface, and then we have ion lens, and then we're moving on to mass filter, which is quadruple filter, and then we have a electron multiplier to be detected by your detector. All right, so we have a little bit of additional instrumentation part lah. All right, so this is ion source. So this is the interface from your ICP, from your plasma. Your ions will be subjected to a sampler cone, and then moving on onto a schema cone. So basically, we also have the definition of what are the sampler cone, what is the schema cone. So what happens to your ions actually through this kind of filtration lah, basically. All right. So and then we'll be moving on onto the ion beam focusing system, which is the lens assembly. It focuses the ions from your schema tadi tu onto the quadruple after this. All right. So the quadruple, which is the mass filter, you need also to remember that the quadruple rods only allow one mass to make it through at a time. Means that the detection would be based on the mass one at a time. So basically kalau kita tengok dekat spectrum ini, so basically the first one that has been detected is lithium lah. Okay. Followed by carbon. Right. So, and then what are the applications of ICP-MS? Okay, what are the differences between ICP-MS and ICP-OES? Whether the advantages, what are the disadvantages? So you need to know, right? And then lastly, we have looked into the criteria on how are you going to choose for both. When you have a sample, when you have your analyte, how are you going to choose on whether you want to go to the highest, to the very high end, which is ICP-MS, or you just want to use flame AS, which is much more cheaper. So these are the decision criteria if you want to choose which instrument to use, right? So as I mentioned before, it is good if you have this kind of table of comparing of all of the absorption or emission spectroscopy. You need to know about the differences between them. You need to know about the advantages, also disadvantages among them. All right. And then, okay. So I also posted a forum question inside your e-learning. So basically, the first question is about the source of radiation of absorption and emission spectroscopy. All right. So basically, I've looked into your answers and some are correct and some are misleading sikit lah. In terms of absorption, source of radiation for absorption spectroscopy, I don't think you have any problem because we have a source of light dekat depan tu, okay, before the flame. But for emission spectroscopy, the source of radiation or source of emission is from the analyte itself. It's not from the plasma. Okay, so the plasma is only there for atomization processes where it will make your atoms into the excited state. Because of the very high temperature, your atoms will have enough energy to go from ground state to an excited state. But as an excited state is not stable, it will go back down to ground state due to the relaxation process. So this relaxation process will generate an emission wavelength which will be detected by your detector. Alright. Kalau kita tengok in terms of absorption spectroscopy, the source comes from the HCl ke EDL. So it's very specific on the analyte itself inside the flame. So when your source of radiation hit your being absorbed by your analyte inside the flame, so the transmittance is going to be is going to be calculated lah. So that is for absorption spectroscopy. So the source of radiation comes from the HCl. But for emission spectroscopy, it comes from the analyte itself. So that's why emission spectroscopy can have a simultaneous detection because all of the emission lines comes from the sample can be detected simultaneously by your detector, which is CCD. Okay. So the advantages of absorption, the second question is advantages of absorption and emission over one another. All right, so I think for this question, I don't think we have any problem because I've looked at most of you has referred back to the slides lah in terms of absorption. We the price is much more lower as compared to emission spectroscopy, but for emission we can have much more analyte that can be detected simultaneously. Alright? Okay, up until this point, ada soalan? Any question? Azrin Syafiqah, are you in the meeting? Ada soalan tak Azrin Syafiqah?
Doktor, setakat ni tak ada lagi.
Tak ada lagi, semua clear ya?
Boleh faham.
Boleh faham. Okay. Alright. So in that case, maybe we will have some Kahoot. Okay ke? Boleh ke? Boleh ya, respon lah sikit. Bukalah mic tu.
Ya, doktor.
Okay, Doktor.
Boleh doktor.
Boleh. Okay, alright. Sekejap ya. Mana saya beri Kahoot ni? Sekejap. Sekejap lambat pula loading. Okay, nampak tak screen? Can you see my screen?
Boleh,
doktor.
doktor. Yes.
Alright. Okay, we have 44 now. Okay, we have about 62 participants minus me and Dr. Amy. So about 60. So about 54. 53 pula. Okay. Mana lagi? Mana lagi? Okay, maybe ada problem kot, tak apa. I think that we can start now. So for those yang tak dapat nak join, you can see the video on later on lah. Alright, so so this Kahoot is going to be for chapter 3 and chapter 4 lah. So as you guys said macam tak ada soalan. So hopefully semua dapat jawab lah soalan ni ya. Alright, so I'll start now ya. Okay. Can I get some response? Okay.
Okey, Doktor.
Okay, Doktor.
Okay, bagus. Saya start Alright, true or false? Atomic absorption spectroscopy employ the use of emitted wavelength from the analyte. Betul atau salah? Alright, so the answer is false, yeah. So atomic absorption spectroscopy employ the use of emitted wavelength. So salah lah, because here atomic absorption spectroscopy should not use emitted wavelength. Alright, so atomic emission spectroscopy using emitted wavelength from the analyte. So 35 people answer yang betul lah. So this 21 ni macam mana? Alright, so faham ya for that one. So I go to the next question. So siapa yang leading? Okay, low leading. Alright, next question. True or false again? ICP-OES measures the emission of radiation from an excited atom to the ground state. Betul ataupun salah? True or false? Alright, so yes, majority of you said true. So only 4 people salah. Alright, so yes, ICP-OES measures the emission of radiation and from an excited atom to the ground state. Alright, so alright, Randy is leading now. Alright, next question. The analysis of Alright, the question, okay, I rasa tak apa, ini soalan salah kot. I salah tulis. The analysis of mercury, sorry. Mercury is best using, was supposed to be mercury lah. Tak apa. Alright, so the correct answer is cold vapor, okay? So because this question, sorry saya salah soalan. So the analysis of mercury is best using cold vapor AES, yeah? So Azrin is leading now. Alright. So ionization is desired in AAS. Betul ke salah? Is this correct? Do we want ionization in AAS? So the answer is false here. So those 21 students, okay, so the ionization is not desired in AAS, but ionization is desired in ICP-MS because the separation is going to be based on the ions in the mass spectrometry. All right? Okay. So Chiu is leading now. All right, good. All right, true or false? The hollow cathode lamp did consist of several elements at the cathode. Betul ke salah? Ah. So, 28 of you answer correctly. So the hollow cathode lamp did not consist of several elements. It only consists one element at the cathode. So as I mentioned before, for hollow cathode lamp, if you are analyzing copper in your sample, so your hollow cathode lamp need to be a copper hollow cathode lamp because at the cathode is only going to be copper. Okay, so hollow cathode lamp does not consist several elements at the cathode. It only consists one type of element. All right. So these 24 students. Okay. So you need to know that. All right. Hassan now is leading. All right. Which statement is false? Graphite furnace require longer analysis. Sample for flame AS can be liquid, slurry, and solids. Sample preparation is minimized in graphite furnace. Sample for flame AS is continuously aspirated into the flame. So which one is false? 3 betul, ada 1 je salah. Alright, so only less than half of you, okay? So the sample, the correct answer is, I mean that the false statement is sample for flame AS can be liquid, slurry, and solid. The correct answer is that sample for flame AS must be in liquid only. Alright, kalau graphite furnace AS, yes, it can be in liquid, slurry, and solid. Alright, so all of the other statements is correct. Right. Alright, Hassan is still leading. Faikah is the highest answer streak, okay? Alright, good job. How do we achieve background correction is in flame AAS? Background correction. Macam mana nak buat background correction? Alright, so the correct answer is by having a beam chopper. Alright, so because the beam chopper, if you remember that when I say that the beam chopper alternate the signal from your flame and also from your source of light, which is HCl. Alright, so this alternation, this alternate of signal from your source and your flame would create the differences would create your correct analyte concentration. Alright. Alright, Faika. Alright, good job. Which is true regarding emission spectroscopy? Which is true? So it measures the emission from the flame. All atoms are excited simultaneously. Right? Which is true. All right, so the correct answer is All atoms are excited simultaneously in emission spectroscopy. All right, so who is the highest? Oh, Faika again. All right, good job, Faika. All right, next question. True or false? Ionization in ICP-MS is desirable. Dah sebut banyak kali dah. Alright, true. Okay, in AAS yang tidak desirable ya. Alright, so Faika is the highest now. Good job, good job. Alright, last question. Quadruple mass filter only permits one mass of ions to make through at a time. Betul ke? Is it true? Okay, it's true, okay? So only one mass of ions to make it through at a time. Alright. So 19 lagi ni saya tak sure, tak tahu ke ataupun saja je buat apa? Buat salah ke, alright? So at the podium, the third place goes to Arif. Okay, congratulations Arif. Gan, the second place. The first place is? Who's the first place? Faika. Alright, congratulations. Alright, so saya akan screenshot ni. Screenshot ke? Okay. Alright. Okay. So, apart from this, ada soalan ke lagi? Do you guys have any question? Ya, saya tutup dulu. Ada soalan ke? Tak nak jawab ke? Hello? Ada soalan tak?
Tak ada betul.
Tak ada, okay. Alright, so, okay. So, siapa yang tak sempat, apa? Tak sempat scan class attendance tadi, sekejap. Ya, saya buka semula. Dan lagi 2 minit, okay, tak apa. Share. Alright. So whoever have not scanned this attendance code, please do so. Okay. So lagi berapa orang? Okay. Alright. So so basically next week we will continue on chapter 5. Alright. So as usual lah, we will have I will record your lecture. So you will be looking onto the lecture starting from Sunday lah. From Sunday. So on Thursday, we will have a discussion like this. Okay? Okay ke semua? Kalau macam tu, kita buat macam tu lah senang. Okay ke?
Okay.
Okey, doktor.
Alright. Okay. Okay, kalau dah tak ada apa-apa. Ada soalan ke?
Doctor, I want to ask about the test, when it will be.
The test?
Yeah.
Okay, the test was supposed to be, I think in week, if I'm not mistaken, is going to be at week 10, if I'm not mistaken. Week 8, yeah. Because I've already changed it because senang apa, for me to have the lectures together lah. I think in week 10, if I'm not mistaken, the one that I already briefed during your introduction class. Never mind. I will look at back and then I will notify all of you back inside the WhatsApp group. Okay ke?
Okay.
Alright, yeah.
Okay. Thank you, Doctor.
So the nearest is going to be on week 6 because we will have our quiz 2 on week 6. Alright, so this is week 4. Next week is week 5. So week 6 we will have our quiz 2. That's the nearest assessment for all of you lah. Okay, so if there is no more question, maybe all of you can leave the meeting. And for those who have not scanned the QR code, you still have time to scan the QR code before I close it. Thank you, everyone.
Thank you, Reza.
Thank you, Doktor.
Okay, Doctor.
Banyak pula lah suara ujung-ujung ni. Tadi tanya tak ada siapa pun bercakap. Yang lain ni tak nak keluar ke? Okay.